Dear student, this is a lecture 5 of Z transform, and in this video I am going to discuss how to find out the inverse of Z transformation. There are three methods that are used for the evaluation of inverse Z transform. One is partial fraction expansion method, long division method, also called power series expansion method, and contour integration method or residue method. Now, first of all, we will discuss partial fraction expansion method to find out the inverse Z transform. Now let's start with this numerical. Find the inverse Z transform of xz is equal to 1 minus Z inverse plus Z raised to the power minus 2 divided by 1 minus 1 upon 2 Z inverse, 1 minus 2 Z inverse, 1 minus Z inverse with ROC mod Z is greater than 1 and less than 2. Now let's start with the solution. For simplification, we will eliminate the negative powers of Z and we will write xz as the positive powers of Z by multiplying by Z raised to the power 3 in the numerator and denominator both. We get this. Now we can take Z common from this expression and we can write xz upon Z is equal to Z square minus Z plus 1 divided by Z minus 1 by 2, Z minus 2, Z minus 1. Now we will apply the partial fraction expansion. For that we have written a1 upon Z minus 1 by 2 plus a2 upon Z minus 2 plus a3 upon Z minus 3. Now we will find out the value of a1, a2 and a3. Now to find the value of a1, we will find it like this. We get 1, a2 we obtain 2 and a3 we got minus 2. After putting these value of a1, a2, a3, we get xz upon Z is equal to 1 upon Z minus 1 by 2 plus 2 upon Z minus 2 minus 2 upon Z minus 1. Afterwards, we will multiply this Z with these expression. Now, we get xz is equal to Z upon Z minus 1 by 2, 2Z upon Z minus 2 minus 2Z upon Z minus 1. Now, we will take Z common from numerator and denominator and we get this 1 upon 1 minus 1 by 2 Z inverse, 2 upon 1 minus 2 Z inverse minus 2 upon 1 minus Z inverse. Now we will apply the inverse Z transform on these terms separately. First, we will see what is the ROC. This ROC is given that mod Z is greater than 1 and less than 2. So once we will make the ROC, draw the ROC, we will get this ring. 3 poles are there. Z is equal to 1 by 2, Z is equal to 2 and Z is equal to 1. So we get these 3 poles 1 by 2, 1 and 2. Now and the ROC is this. So now we'll start the discussion from first expression. Pole of first term is equal to 1 by 2. So ROC has a radius greater than this pole, as we can see from the ROC that is given, this one. So xn which we are going to obtain will be right sided. So inverse Z transform of 1 minus 1 upon 2 Z inverse will be 1 by 2 raised to the power n un. In the same way, second term at pole Z is equal to 2. From the ROC we can see that mod Z is less than 2. So xn which we are going to obtain will be left sided. It is left sided. So 1 upon 1 minus 2 Z inverse. So we get 1 upon 1 minus 2 z inverse. Its inverse will be minus 2 raised to the power n u minus n minus 1. Now we will see the third term, that is at z is equal to 1. From the ROC we can see that the ROC has a radius greater than this pole. So action will be right sided, and we'll get inverse of 1 upon 1 minus z inverse is equal to un. So action, we get action 1 by 2 raised to the power n un minus 2 into 2 raised to the power n u minus n minus 1 minus 2 un. Thank you. These are the references. Thank you.